So in the last video, what we met was that we had two key trig identities. If you didn't watch the last video, then the two key trig identities you need to know are that tan x is the same as sine x over cos x. And that is identity number one. And the second identity is that sine squared x plus cos squared x equals 1. And actually, we've got various versions of that second formula. And those versions we will meet a little bit later on. To start with, both examples we're going to use to start with are going to use this first identity. Now, these questions, you can identify them easily. They always start with the word prove or show that. And they have an equation where the two sides both have like tans and coses and sines on them. And if you take a question like this, the first thing we want to do, if you're asked to prove something, you want to start with one of your sides, do some working, and finish with your other side. And the way we like to write that, and I'm going to abbreviate it, but we write LHS to stand for left-hand side. Well, what is our left-hand side here? It is tan x 1 minus cos x. So I'm just rewriting the left-hand side. Not worried about what it's equal to. That's what we're trying to get to. We're going to expand that. So tan x times 1 is tan x. Take away. Well, next one, tan x times cos x. And I'm always kind of checking back. Oh, that matches tan x and tan x. Well, that's a good start. So we maybe need to work on this term a bit more. So let's leave our tan x there. But we want to do something with this. The only thing I can see to do with that is rewrite tan x using our trig identity, which we started with. So let's put that in. Well, tan x is sine x over cos x times another cos x, because that is there. Now, if I'm multiplying a fraction by something, so if I multiply, say, 3/4 by 4, the 4's cancel out. It's the same with cos x. It's the sine x over cos x times the cos x. The cos x and the cos x cancel out with each other. Well, what does that leave us with? Well, it leaves us with tan x minus sine x. That's good because it's exactly what our right-hand side here is. And so I'll always write that when I finish. So that is equal to the right-hand side of our expression. And so we are done. Now, let's have a go at your turn. Pause the video, have a go. Slightly different looking one, this, but similar ideas coming in. So have a go at it, see how you get on, and I'll run through it in a moment in video. Okay, hopefully you've had a go. Again, we're going to start left-hand side equals. Well, the left-hand side is cos x tan x all over sine x. Well, there's not much I can do to start this question except for change the tan x. So let's do that. So that becomes cos x times sine x over cos x, because that's what tan is, using our identity, over sine x. Now again, we're going to use that trick with cancelling. So cos x times sine x over cos x, the cos x's cancel out. So we're just left with the sine x on the top line. So although it looked horrible with our double-decker fraction, don't panic. Just look for something you can do, something you can cancel out. Now, sine x divided by sine x, that's something divided by itself, like 4 divided by 4 is 1. A million divided by a million, still 1. So sine x divided by sine x equals 1. And that is what we had on our right-hand side. And so we're finished. Now, we're going to do two slightly harder ones involving our second identity, that sine squared plus cos squared equals 1 identity. So let's do that. I'll lead you through the first one, and then I'll leave you with the second one as your turn. So what do we have? Well, we have here cos squared minus sine squared on our left-hand side. So our left-hand side is cos squared cos squared x minus sine squared x. Now, we want to change this somehow. And this is where we've got to think about our identity a little bit more, because we have that sine squared x plus cos squared x equals 1. Down here, I'm looking at where I'm trying to get to. I'm trying to get only cos's in this thing. So it'd be handy if we replaced our sine squared x, but our sine squared x will take cos squared off both sides of this. We get 1 minus cos squared x. And it's this one here, although it's a slight change from up here, this is what we're going to put in. So let's do that. So we have cos squared x take away 1 minus cos squared x. And I'm actually going to put brackets around that because I need to be really careful that I've got a minus there. Well, let's follow that through. So that is cos squared x. Take away 1, take away minus cos squared x. We'll take away a minus as a plus. Cos squared x. Finally, we've got cos squared x there and a cos squared x there. So we've got 2 of them. Take away 1, and that's our right-hand side. So these are getting a little bit trickier as we go, but that's us achieved that one. Now, the next one requires both identities. So I'm going to leave it as your turn, but I'm also going to leave both identities there, the tan x one and the sine squared plus cos squared one. See how you get on, pause it, have a go, and then I will run through that in a moment. Great, so hopefully you paused, you've had a go. The left-hand side equals tan squared x plus 1. Now, there's not much I can do with that, but I have got a tan x, and so that first identity, tan x equals sine x over cos x, is going to come in. So that is sine x over cos x plus 1. Now, you might spot there's a squared here. Don't forget about it. So we'll put the squared on. Well, if I square a fraction, I can just square the top. So that is sine squared x. I can square the bottom, cos squared x. So just squaring a fraction, square the top, square the bottom, plus 1. Now, if you got that far, well done. You're doing really, really well, because the next step is a trick that you will get used to once you've seen it. But first time you meet it is something that you just have to kind of look at and go, oh yeah, that kind of works. So if we had numbers and I was adding a 1 to it onto a fraction, I could actually say I was adding fifths. I could rewrite my 1 as 5 over 5. Now we're going to use the same trick here. We're wanting to write that 1 with a cos squared x on the bottom so that we can add it. Well, if I want 1, I have to divide something by itself. So that must be cos squared x divided by cos squared x. Now we're nearly there. Hang in there. Same denominator. So we can write it as sine squared x plus cos squared x all over that denominator, which is cos squared x. This might look like a mess, but sine squared plus cos squared, well, we've met that before. That is our second identity. So as soon as we see that, sine squared plus cos squared, we can change it to a 1. So that becomes 1 over cos squared x. And hey presto, that is our right-hand side. So we are finished. Okay, so these can get quite tricky. You know, these ones are not easy, but have a go at the questions, see how you get on. It's all about just getting the practice, working your way through lots of them, getting familiar with some of the key techniques. What you'll realize after you've done a few is that they kind of begin to look the same. So you're either using a little rearranged version like this to get rid of one of either cos squared or sine squared, or you're spotting a sine squared plus cos squared and changing it to 1, or you're spotting a tan and changing it into sines and coses. Those are the key tricks that you just need to be watching out for and able to use.